evening, teachers and classmates, and welcome to a new calculus tutorial for solving related rates using the law of cosines. And today, we will have the pleasure to solve a problem involving a baseball diamond. So that's why I'm wearing my Yankees cap, because if you can recall, Mariano Rivera recently entered to the Hall of Fame, and I'm sure that with this tutorial you will enter to the Calculus Hall of Fame. So let's begin. Step number 1. Read and annotate the problem. So the problem here says, a baseball diamond has sides of 90 feet. A batter hits a ball toward second base at 80 feet per second and runs toward first base at a rate of 30 feet per second. At what rate does the distance between the ball and the batter change when the runner has covered 1/3 of the distance to first base? Hint: use the law of cosines. Now, step number 2 asks to please draw a diagram with all relevant numbers and shapes. So here I have step number 2 already done. Now, as you can see, here is the baseball diamond with all relevant numbers and the shape of the court. And step number 3 says that set up the given and missing variables and be careful not to leave anything out. But now, a tip that helps me a lot when solving these related rates kind of problems is using a word that I invented. Here it is, forgifiso. So the first syllable of the word stands for formula, the second stands for the givens, the third stands for finding the missing variable, and the fourth and last one stands for solving the problem. Now we're going to solve the problem. Continuing to solve our problem, we should make a clear diagram. So we will make our baseball diamond. It is not perfect, but it is something. Now, remember that this is a perfect diamond, a square. So, we have that each corner will measure 90 degrees. So now, we will put a 90-degree sign here. And now, we're gonna write that this one will be home, this one will be first base, this one will be second base, and this one will be third base. Now, the problem says that the batter is here and the batter hits the ball towards second base. So our ball will make a path towards second base. And now, when the batter is running toward first base, it runs at a rate of 30 feet per second. So what we are missing is the rate of change between the ball and the batter. We're missing this. Now, I'm gonna draw a small triangle that resembles this one in order for you to understand what am I talking about. So here we have our triangle, and now I will call this side C, this side Y, and this side X. Now, the problem also states that the batter covered a distance of 1/3 of the total side. So it will be 1/3 of 90 feet, which will be 30 feet. So x will be equal to 30 feet. This is a condition. We can proceed to understand some of the syllables in our word. The first syllable stands for formula, so we need to find the formula in order to solve the problem. So we can use the hint before given in the problem, which is using the law of cosines. So here it is. Y squared is equal to x squared plus c squared minus 2 times x times c times the cosine of theta. Remember that if the batter hit the ball directly towards second base, this means that our theta will not be 90 degrees but 45 degrees. Now, we can solve for the second syllable, which stands for givens. Now we have our givens, which are dx over dt, which is the rate at which the batter is reaching first base at 30 feet per second. And we have our second given in here, which is dc over dt, which is the rate at which the ball is reaching second base, or 80 feet per second. Now we have to look for our third syllable, which stands for finding the missing variable. And what are we missing? We're missing the rate of change between the ball and the batter. So this will stand for dy over dt. When the condition of 1/3 the distance is covered, so x must be 30, and with this we can find our missing variable. Now, a question that is usually asked is how can we find c? Because we have already dx over dt, we have dc over dt, and we have already our x, which is the distance covered by the batter, or 1/3 the total distance, which is 30 feet. But we don't have c. So let's assume that the time it took was 1 second. Then we can replace our values in the distance velocity time formula. And the distance will be equal to 80 feet per second, which is the rate or velocity, times 1 second. And the distance will be 80 feet. So our c is gonna be equal to 80 feet. And last variable of our word stands for solving the problem. So step 5 asks to find an equation that relates all variables. So we're gonna use the law of cosines in order to solve this problem, which is y squared is equal to x squared plus c squared minus 2 times x times c times the cosine of theta. And we need to recall that this is a perfect square. So each of our corners will measure 90 degrees. And if the batter hits the ball right here, this means that our theta will measure 45 degrees. And we are using the law of cosines in order to solve the problem, because remember that this is not a right triangle. So now we continue by taking the derivative of our equation using implicit differentiation. And here we have that the derivative of y squared is 2 times y times dy over dt is equal to the derivative of x squared, which is 2 times x times dx over dt, plus the derivative of c squared, which is 2 times c times dc over dt, minus 2 times the cosine of theta, which is the cosine of 45. And here, as you can see, we have our little product rule. So we have to multiply x times the derivative of c, which is dc over dt, plus c times the derivative of x, which is dx over dt. Now we continue solving our problem, and here I will prefer to do this step first, because we know the cosine of 45 is square root of 2 over 2. So because they are multiplying, we can cancel each other. And then we continue in order to isolate for the rate of change between the batter and the ball. And we will finally have dy over dt is equal to 2 times x times dx over dt plus 2 times c times dc over dt minus square root of 2 times the product rule of x and c, which is x times dc over dt plus c times dx over dt over 2y. And as you can notice, we have all our variables except y. So what can we do? We can use the law of cosines again. So now we can isolate for y, which will be all square root of x squared plus c squared minus 2x times c times the cosine of theta. And we substitute the numbers into our variables, so it will be 30 feet squared plus 80 feet squared minus 2 times 30 feet times 80 feet times the cosine of 45, and we will finally get that y is equal to 62.497 feet. And then we substitute this y into our equation, and then finally we can substitute all the variables that we have in order to find our answer. So dy over dt is equal to 2 times 30 feet times the rate, which is 30 feet per second, plus 2 times 80 feet, which was the c that we already find, times the rate, which is 80 feet per second, minus square root of 2 times the product rule, which was 30 feet times 80 feet plus 80 feet times 30 feet, over, and remember this part, 2 times 62.497 feet, which was the y that we already found. And finally, we will get that dy dt is equal to 62.497 feet per second, which is the same as 62.50 feet per second.